Alright, so in problem 13, we have a dozen cities here, and we are looking at the mean high temperature between January and July. So they want us to do a 90% confidence interval, and then and we're also going to do a hypothesis test here. So let's do both, okay? So here's what we got to do. You got to put the data in your calculator, and I am going to do an L3. Just going to clear that out. So I'm going to do L2. I'm going to do the high temperatures. I'm going to do, my difference is July minus January. So I did L2 minus L1. Okay. So if I was doing a confidence interval here, mu of D equals the mean difference in temp degrees Fahrenheit between July and January. Okay, the assumptions here. Let's see, I do not believe that these were randomly selected. So these temperatures are representative. Since we did a dozen cities in July and in June, we paired them. So this is paired data, not independent samples. Okay. And then 12 is less than 10% of all temperatures. Okay, there's other cities. And then the last thing I do is check the normal conditions. So we're going to do plot on, and we're going to do a histogram for L3. And we're going to go to zoom stat. Okay, so there you go. So that gets copied down on your paper. And just a rough sketch. Alright, put that in there. Something like that. And then, okay, this one could be an outlier. It's possible. We could, I don't think it is, but we could check it. Let's go to modified box plot. Ooh, it is an outlier. Okay, so we want to note that. Okay, so let's see what difference is an outlier. The 55. Okay, so let's go and see. The 55 is an outlier. Okay, so that's the second to the last one. That's Moscow. If you look, 76 minus 21. So Moscow is an outlier. So we want to proceed with caution. Because Moscow is an outlier. You know, the problem with Moscow is the winters are very cold, and I guess summers aren't real hot, but they're 50 degrees warmer, so the average temperature. So this is a match paired confidence interval, and we got to get summary statistics. So we're going to get our summary statistics off of L3. So we're going to calc 1 var stats. Let me clear that out. We're going to do 1 var stats for L3. And our mean difference is 36.83, and our standard deviation is 8.664. So x bar of the difference is 36.83. Standard deviation of the difference is 8.664, and then n is 12, so degrees of freedom is 11. The interval is going to be x bar plus or minus. Now we got to get a t with 11 degrees of freedom. Okay, and we are doing a 90% confidence interval. So again, if I'm doing a 90% confidence interval, shade in the middle 90%, then this starts at the 5th percentile and ends at the 95th percentile. Okay, so we got to go with the second distribution, inverse t, and we're going to do 0.95 with 11 degrees of freedom, and you get T distribution of 1.796. Okay, so this is going to be plus or minus 1.796 times the standard deviation over the square root of n. Okay, at that point, now that you have the data, I mean the stats, you can put them in here. You could fill in x bar, standard deviation. The thing is, we rounded them, so I'm going to use the data, and I'm going to say, okay, I want to use the data in L3, okay, and I want to do a 90% confidence interval. That's my deal, okay, and that calculates. So that's 32.3 to 41.3. So the conclusion is we are 90% confident that the average temperature is between 32.3 degrees Fahrenheit and 41.3 degrees Fahrenheit warmer in July than in June. Okay, so it appears that we're looking at these European cities. So, well, what does that mean? Well, it looks like it's warmer in Europe in the summer than it is in the winter. Surprise, surprise. Now, again, we did a 90% confidence interval. So if I was doing a hypothesis test, my null would be this. My alternative would be, I'm assuming the summer is going to be higher. Okay. So my Z, you know, we already did P, VH, DA. The name of this would be a match pair t-test. And then we already did the statistics. So T would equal the mean difference, which is 36.83, minus 0. Okay. Over the standard deviation over the square root of n. So that's what my T, and this would have 11 degrees of freedom. So I'm going to go and do this test now. So we're gonna, I'm gonna reject this because we already rejected this because 0 is not in our interval. So let's go to t-test. We're going to use data. The difference is going to be 0. That's our hypothesized difference. We're pulling off L3 since those are where the differences are. We're trying to see that L3 is positive because we did summer minus winter, and we're going to draw that up. Okay. Now remember, a 90% confidence interval coincides with a one-tail test, and we're doing a one-tail test. So our p-value is 0, and our t-value is 14.7. So we hit this here. So we got a p, big P equals 0. So our mean difference. So if our mean difference was 0, well, that's our hypothesized difference. There's a 0% chance of us getting the average difference that we got if this is true. So obviously we would reject H of O at the 0.05 level because a 90% confidence interval coincides with a one-tail test at a 5% significance level. And then our conclusion would be there is very strong evidence that the average temperature in Europe is warmer in the summer than in the winter. And that's how we write that up.